Okay, so we've talked about two methods of solving quadratics. The first one was graphing. The second one's factoring, but not everything can be graphed accurately. Not all the answers from a graph are accurate. Not everything can be factored. So now we're going to look at our third method, which is solving quadratics by using square roots. So square roots look like this. The nice thing about square roots is when I square root 3 squared, the square root cancels out a square to leave me with the number 3. It's an inverse operation. And so we're going to be using that to help us out. So some quadratic equations cannot easily be solved by factoring. Square roots can be used to solve some of the quadratic equations. Recall from lesson 1.5 that every positive real number has 2 square roots, 1 positive, 1 negative. So again, back up here, when we're looking at this really isn't 3. This is positive and negative 3. So every time I square root, I'm going to get a positive answer, but I'm also going to get a negative answer. And so we're going to be using this idea to help us out. Because we're going to be solving for x, we can't tell what the number inside is going to be. And so that's where we're going to get positive and negative x possibilities. So we're going to use something called the square root property. And that says that to solve a quadratic equation in the form of x squared equals a, what we're going to do is we're going to take the square root of both sides. So we're going to have x squared equals a. We square root both sides, and then we get the answer x equals positive or negative square root of a. And so the positive or negative, just because we're too lazy to write out two different answers, we put plus and minus in front of it to show that we have a positive square root of a and we have a negative square root of a. So just to start off simple, we're going to solve the following equations. X squared equals 25, so we would square root both sides. That's going to cancel out the squared, leaving us with x. And on this side, we're going to have plus or minus the square root of 25. Well, what is the square root of 25? It's 5. So x equals plus or minus 5. So now we'll move on to the next one. Again, square rooting both sides. So x equals plus or minus square root of 169. If you don't know, check it out on your calculator. Type in square root of 169, and you're going to find that this is positive and negative 13. And then we get to our next one where we square root both sides, and we get to our little caveat. And so our caveat is as long as a is positive. So when I square root a number that's not positive, all of a sudden we get no solution. We cannot square root a negative number. Okay, so that's our simple stuff, and of course we're going to build upon this. So if it's necessary, so on our last problems we had x squared all by itself. What if x squared is not all by itself? Well, then it's necessary to use inverse operations to move things to the other side. So here's my x squared, and it's not by itself on that side. I have a minus 4. So I use the inverse operation by adding 4 to move it to the other side. Because this now turns into 0, so now I have x squared equals 16, and now I can square root both sides. So now I get x equals positive and negative 4, because the square root of 16 is 4. So on our next problem, do the same sort of thing. X squared plus 20 equals 101. So I move the 20 by subtracting on both sides. So this turns into 0. I get x squared equals 81. Now we square root both sides. So I get x equals positive and negative, and the square root of 81 is 9. So there's our answer. So on the next one, we're going to do the same sort of thing. We have negative 2x squared. So that's negative 2 times x squared. To undo times, we're going to divide. So the 2's cancel, the negatives cancel. We now have x squared equals positive 16, because the negatives cancel out. We now square root both sides, and x is equal to positive negative Square root of 16 is 4. Okay, so our next one, x squared divided by 2. So the opposite of divide by 2 is times by 2. So the 2's cancel now, because 2 divided by 2 is 1. So it gives me 1x squared, which is just x squared, equals 64. Now I square root both sides, and I get x equals positive and negative 8, because the square root of 64 is 8. So now we're going to get a little bit more complicated. We now have 16x squared plus or minus 49 equals 0. So now we do same thing, order of operations. I do the opposite of order of operations. So I move my pluses or minuses first. So I'm going to add 49. I now have 16x squared equals 7. Or I don't know why I said 7. That's 49. I now divide by the 16. So I get x squared equals 49 over 16. And then I square root both sides. Now when I'm square rooting, I'm going to have a plus or minus, and I'm allowed to break this up. Square root of 49 over square root of 16. We can break up over division or multiplication, not addition or subtraction. So this really becomes x equals plus or minus 7 over 4. And that's our answer. So we can still get those fractional answers by using our algebra. And our next one, same idea. I add 9 to both sides. So I have 100 x squared equals 9. I divide by 100. So now I get x squared equals 9 over 100. I now square root. So x equals positive and negative. The square root of 9 is 3. Square root of 100 is 10. And there's our answer. So as you can tell, I'm only on page 2 of 5 because we're slowly getting more and more complicated. And we're building up to another method. So now, all of a sudden, I have x minus 5 squared equals 16. So if this whole thing is squared, I can't move the 5 because it's inside the parentheses. I have to get rid of the square first. So now I'm going to square root both sides. So now I have that x minus 5, because this will cancel out the squared. So I'm left with x minus 5 equals positive or negative, and the square root of 16 is 4. So really I have two equations. I have x minus 5 equals 4, and I have x minus 5 equals negative 4. Because of the different signs, we're going to get different answers. And now I just solve each equation. I add 5 to both sides, and I get x equals 9. Here I add 5 to both sides, and I get x equals 1. So again, two answers, but this time they're different values. So on the next one, very similar, I square root both sides. So now this will cancel out with the squared, leaving us with that inside 2x plus 1 equals positive or negative 5. I now separate it out. 2x plus 1 equals 5. 2x plus 1 equals negative 5. And I solve each equation. I minus 1 on both sides. So now I get 2x equals 4. Divide by 2. And I get x equals 2. Here I minus 1 on both sides. So now I get 2x equals negative 6. Divide by 2. And I get x equals negative 3. So now I have my two answers, 2 and negative 3, and we are good to go. But as you can tell, we're still on only page 3 of 5, because we're building you up step by step. So when solving quadratic equations by using square roots, you may need to find the square root of a number that's not a perfect square. So if it's not a perfect square, you're going to need a calculator nearby. So I'm going to grab my calculator if you can't hear me right now. And we're going to go ahead and work on solving some that need calculators. Okay, so the first thing I want to do is I want to get that squared part by itself. So I'm going to divide by 3 on both sides. So now I have x minus 1 squared equals 5. Now I square root both sides. So that gets rid of the squared. I now have x minus 1 equals positive or negative square root of 5. So I'm going to figure out what the square root of 5 is. Square root 5. And I get 2.2361. Typically we want 4 decimals to stay safe. And now we're going to break this up. X minus 1 equals 2.2361, and x minus 1 equals negative 2.2361. So here I add 1 to both sides. So I get x equals 3.2361, and then I add 1 to both sides. So this is going to be x equals negative 1.2361. And these are our 2 answers. So on our next one, very similar, we're going to get the x squared by itself, so I add 10 to both sides. So now I have x squared equals 35. I now square root both sides. So now I have to calculate the square root of 35. And I'm going to get positive or negative 5.9161. Again, 4 decimal places to keep as accurate as we can, because after that, it's just a minuscule amount. Unless you're multiplying by 1,000,000, then it's not minuscule anymore. Okay, so let's look at another problem. Oh, now we're just reviewing all the different ones that we have. Again, using the idea that we want to get the squared part by itself and then square root on both sides. So, x squared minus 195 equals 1. So I add 195 to both sides. So now I get x squared equals 196. I square root both sides. So I'm not sure what that is. Actually, I know what it is, but... And I get x equals positive or negative 14. And you're going to find that you do the square roots and the squares all the time in geometry. So that's something that's going to keep popping up through time. Okay, next one, I add 18 to both sides. So now I get 4x squared equals 9. Divide by 4. So I get x squared equals 9 over 4. I square root both sides. So x equals positive or negative square root of 9 is 3. Square root of 4 is 2. And there's our answer. So our next one looks like we've got the squared. So I square root both sides. That's going to cancel with that, giving me x plus 7 equals positive or negative 9. I split it up. X plus 7 equals 9. X plus 7 equals negative 9. So I minus 7 on both sides. I get x equals 2. I minus 7 on both sides. And I get x equals negative 16. Okay, last one. Let's move the 225. So negative 225. So negative 225 equals negative 5x squared. I divide by negative 5 on both sides. Good, that's not going to be negative. So let's see, 225 divided by 5 gives me 45. So I'm going to have 45 equals x squared. I square root both sides. So now I'm going to square root my 45. And I get x equals positive or negative 6.7082. Now at the end of the semester, we're actually going to talk about a way to simplify radicals. You may or may have not seen that in the past, but as we get in higher levels of math, it's a more exact form, because as soon as we start rounding decimals, we end up with an error because we're cutting off numbers over here. And if I were to multiply by 1,000,000, that number, let's see, 1, 2, 3. All of a sudden, I've just cut off 3.9. And if I were to multiply by 10 million, so if we're working with big numbers, that little bit of error becomes bigger and bigger and bigger. And in mathematics, when we're trying to design stuff to withstand earthquakes, hurricanes, that people's lives are at risk, having our math be exact is really, really, really important. And so these are just little tools that we use to help us be as exact as possible.